Hello everyone, my name is Shashank Shekhar. I'm a student of Zoology Honours Hansraj College, and I'll be presenting my topic antibiotic resistance before you, and we'll be covering everything from the dawn of antimicrobial resistance to understanding what is the current issue that we face today. So, when we study about antibiotics, we have to start from the actual beginning, which was the first discovery of the first natural antibiotic by Alexander Fleming. It was in 1928 that Alexander Fleming accidentally discovered penicillin when he noticed that a stray mold, which was later identified to be Penicillium notatum, was growing in an uncleaned culture plate that he had left around in his laboratory. He saw that certain bacteria, which was Staphylococci, would not grow around the region of where this mold was growing. Hence, he suggested that this mold secreted a certain mold juice, as he described it, which was a powerful antibacterial agent, and hence it could be used to purify, used for medicinal uses. Alexander Fleming, however, could not purify and give it in a final form. That work was done in 1939 by two researchers by the name of Howard Florey and Ernst Chain of the Oxford University. They proved its effectiveness in mice in 1940 and conducted the first successful human trials in 1941. The mass success and the legacy of penicillin was established during the aftermath of World War II, where penicillin became a vital tool for treating the Allied soldiers during World War II. This also led to the golden age of medicine, where many such antibiotics were discovered during the period of 1940 to 1960, and there was very rapid development during this period of growth. We will be discussing this in the next slide. Talking about the golden age of antibiotics, which was the 1940 to 1960 period, mass production of penicillin and also discovery of a huge number of antibiotics. As in 1960, as we can see here, there is certain a yellow marked region where as we can see that there is a very large concentration of antibiotics that were being discovered. The main method of discovering these antibiotics was systematically screening soil samples for naturally occurring antimicrobial compounds, as scientists were able to see certain soil bacteria and fungi that used to produce certain antibiotics which were used. Also, the source of this graph is mentioned right here. This graph has been taken from this specific paper published in 2022. So now that we know about antibiotics development, we must also know about the topic of my current presentation, which is the development of antibiotic resistance. Starting from the resistance crisis, the main issue arises that there is a sky high demand of these antibiotics in our current world. However, the supply of new antibiotics has been very shallow. There is a certain gap that is being developed in our ability to treat infections, and also the bacteria is rapidly evolving resistance, which is further giving us a handicap. The second issue is self-defense. As I had already told that the new antibiotics that were discovered came to be after soil screening of samples for soil-dwelling bacteria and fungi. Hence, it is very obvious to assume that the organisms that can develop such antibiotics are also able to develop mechanisms to deter these antibiotics, that is antibiotic resistance. The third issue of development of antibiotic resistance is the primary defense mechanism. The bacteria that are causing harm to us, that develop antibiotic resistance through defense mechanisms that they have evolved over several years through their shortened life cycles. These include antibiotic modification, efflux pumps and sequestration that neutralize the threat of antibiotics. To understand the mechanisms of bacterial defense against antibiotics, I have presented a picture here. There are three different mechanisms mentioned here. First is the efflux pump. Even if your antibody has entered the bacterial cell, the efflux pump works by removing the drugs out of the cell. It is effectively pumping out the drugs out of the cell. The second mechanism involves that the receptor that is supposed to bind to this antibiotic gets targeted and gets modified. Hence, it cannot bind to that specific antibody anymore. The third is that the antibiotic, even if it enters the bacterial cell, it is not, it is getting degraded by enzymes that are produced by the bacteria. Hence, these are three methods that I have presented that cause the development of antibiotic resistance in bacteria. So now that we have studied about what is the issue at hand, we must ask that how can we counter this issue. The first method that has been very common, that has been in research, is the development is the prolonging the lifetime of current antibiotics available. As we are not able to produce a large number of antibodies, novel antibodies, we must make do with what we have right now. Hence, one such method that scientists have been using is using certain adjuvants like clavulanic acid to shield current antibiotics by blocking resistance mechanism. Hence, antibiotic mechanism that have been developed by bacteria gets blocked by adjuvants like clavulanate oral suspension. This is a medicine that I have presented here. It works by blocking that defense mechanism that bacteria have developed, essentially essentially allowing the antibiotic to work on the bacteria. The second is we target the bacterial pathogenicity that weakens the infection, but we should not kill the bacteria. By not killing the bacteria, we are preventing the anthropogenic action that humans have always done to slow down the artificial selection and slow down the development of antibiotic resistance. The second method which can be used as a countermeasure is that we must develop new antibiotics that are effective as well and that show, and this is the best method that we can use. However, the rate of discovering entirely new and low toxicity antibiotics has plummeted. It also requires a large amount of funding and requires a large amount of research which is slow to come by. Finally, I would like to add that modernizing our defense against these microscopic opponents remains a long and difficult journey. However, one thing that we can be sure is that if there is one species capable of winning this battle, it sure is Homo sapiens sapiens. Thank you. My name is Shashank Shekhar.